A very good morning, I beat the Dr. Cook. Today, Nur Alia, will be presenting the justification of my research proposal. So, this will be the agenda for my presentation today. For the first one, I will talk about the current landscape of mathematics education. Second one is the significance and relevance of my research proposal. Then I will talk about the gaps and limitations that exist in the current literature. I will also talk about the proposed research question in my research proposal and the methodology and also the potential impact and implications on mathematics education. And lastly, I will show the references that I use in my presentation. Okay, so here are the current landscape of mathematics education. So basically, we all know that mathematics education plays a crucial role in developing students' analytical and problem solving skills, which are essential for success across various academic and professional domains. And this is stated by Schoenfeld in 2016. However, traditional teaching methods in mathematics have often been criticized for their overemphasis on rote learning and memorization, which leading to a lack of student engagement and poor understanding of concepts. So this issue is particularly evident in the teaching of whole numbers and basic operation, a foundational topic in the Year 6 mathematics curriculum, where many students struggle to grasp the fundamental concepts, ultimately developing a negative attitude towards the subject and underperforming academically. So, in recent years, problem based learning (PBL) has emerged as a promising pedagogical approach that holds the potential to address these challenges in mathematics education. Basically, PBL is a student centered instructional method that emphasizes learning through the exploration and resolution of real world problems, promoting active learning, critical thinking, and the development of problem solving skills. So, numerous studies have demonstrated the effectiveness of PBL in various educational settings, including mathematics, where it has been found to enhance students' motivation, engagement, and conceptual understanding. Moreover, PBL has been shown to foster the development of essential soft skills such as teamwork, communication, and critical thinking, which are crucial for the success in the 21st century. Okay, now we will move to the significance and the relevance of my research proposal with the title An Investigation into the Effectiveness of Problem Based Learning in Improving Mathematics Education Outcomes of Year 6 Whole Numbers and Basic Operation. Okay, this study evaluates problem based learning in improving Year 6 students' mathematics outcomes, focusing on whole numbers and basic operations. It assesses problem based learning impacts on attitudes, academic performance, problem solving, and soft skills development. The findings will inform teachers about the benefits of student centered approaches over traditional methods. It guides the curriculum developers and administrators in enhancing student engagement and achievement in mathematics. The study contributes to innovative teaching techniques and prepares students for future challenges. The results are significant for teachers, administrators, and policymakers, advancing mathematics education practices. So here are the gaps and limitations that exist in the current literature. So, existing literature on problem-based learning in mathematics education has focused on higher or secondary education, and this leaving the gaps in primary school research, especially for the year 6 students. So, previous studies often overlook specific impacts on attitudes, conceptual understanding, and soft skills development, instead, focusing on overall academic achievement. So, this research proposal addresses these gaps by conducting a comprehensive quasi experimental investigation into problem based learning effectiveness of Year 6 students in whole numbers and basic operations. It aims to assess impacts on attitudes, problem solving skills, and soft skills development using a robust research design. By employing this robust research design and a multifaceted assessment approach, this study will contribute to the growing body of evidence on the potential of problem based learning to transform mathematics education and enhance student learning and achievement. Okay, now we will move to the next one, which is the proposed research questions. My research question is the first one: what is the attitude of Year 6 students towards studying whole numbers and basic operations? Second one: what are the differences in academic performance between students who exposed to problem based learning and those in traditional teaching? And the third one is how does problem-based learning affect Year 6 students' mathematical problem-solving abilities and soft skill development? Okay, so this is why the proposed research questions is crucial for advancing understanding in the field of mathematics education. The research questions underpinning this study are designed to delve deep into the potential of problem based learning as a transformative approach to enhance mathematics education outcomes of Year 6 students. Examining the impact of problem based learning on students' attitudes towards learning whole numbers and basic operations is crucial, as fostering positive dispositions and engagement with mathematics is a fundamental prerequisite for developing conceptual understanding and problem solving abilities. Furthermore, comparing the academic performance of students that are exposed to PBL versus traditional teaching methods will provide empirical evidence on the effectiveness of this student centered approach in improving learning and achievement in this foundational mathematics topic. Assessing the influence of problem based learning on students' mathematical problem solving skills and soft skills development, such as critical thinking and collaboration, is paramount for advancing the field of mathematics education. So, in short, the findings of this research will be instrumental in guiding the transformation of mathematics education to better meet the evolving needs of learners in modern era. And now we will go to the methodology that are used in this study. So for the research design, this study will employ a quasi-experimental design to investigate the effectiveness of problem-based learning in improving mathematics education outcomes for Year 6 students in learning whole numbers and basic operations. Here are the sampling method. The study population comprises Year 6 students in primary schools in the Tuaran district. Due to the large population, simple probability sampling or simple random sampling was employed to ensure fair selection of participants for this experimental study. However, the results will not be generalized to all schools. The sampling involves selecting 60 Year 6 students from one school in the Tuaran district who take mathematics subject. The research instrument that I use in this research is pre-test and post-test, and also the inventory Likert scale. So this is my conceptual framework. As you can see, the independent variable for my research is the teaching method, which is the experimental group, problem-based learning, and the control group, traditional teaching. The dependent variable is the mathematical problem-solving skills. There are also some other variables such as moderator variable, mediator variable, and the control variable. The strategy that I use in this research is problem-based learning. Okay. Now we will move to the next one, which is intervention and treatment procedure. So, in the intervention phase, the experiment group will undergo problem based learning sessions focused on whole numbers and basic operations. Pre and post test will assess the initial and final knowledge, the problem solving skills. The teachers will receive problem based learning training, and students will work in small groups on real world problems. The teacher will facilitate the discussions, provide guidance, and assess understanding and soft skills. The problem based learning cycle will repeat with new problems. For the control group, they will receive the traditional teaching on the same topic. Pretest and post-test will evaluate the knowledge, problem-solving skills, while the inventory will evaluate the attitudes and the students' soft skills. The teachers will employ standard curriculum and methods, including lectures and textbook exercise, with assessments through classwork, homework, and quizzes. Okay. For the data collection procedure, this study was conducted after obtaining permission from the school and the result of discussions with the teachers involved. The data collection procedure begins with the researcher giving a pretest to the experimental group and the control group. Then the researcher implemented problem-based teaching in a 1 hour teaching and facilitation session related to the topic of whole numbers and basic operation. After finishing the lesson, the researcher gave a post test within 15 minutes. Next, the researcher gave 10 minutes to give time to the sample of the study, namely the year 6 students, to answer the inventory that had been given and send it back to the researcher. The same procedure was done to the control group, but it was different in the intervention part. That is, the teaching used was the traditional method. The data collection process takes place in different times. The results of the data collection will be analyzed according to the appropriate methodology based on the research questions and fulfilling the research hypothesis. Okay, now we will move to the next one, which is data analysis procedure. To make comparisons and conclude the study data, inferential statistical analysis will be conducted. The selection of specific inferential tests will be based on the research design, the nature of the data, continuous or categorical, and the underlying assumptions of the statistical test. Independent sample t-test or analysis of variance ANOVA will be utilized to compare the mean scores of the treatment group, the problem-based learning, and the control group, traditional teaching, on variables such as the standardized achievement test, problem-solving skills, and academic performance. Paired sample t-tests or repeated measures ANOVA will be used to analyze changes in students' attitudes and performance within each group, comparing pre-test and post-test scores. Correlation analysis, including Pearson's R or Spearman's rho, will be conducted to investigate relationship between variables such as attitudes and problem-solving skills. Okay, and this is the implications of the study of the research on mathematics education. So the findings of this study on problem-based learning in Year 6 mathematics education can revolutionize teaching practices, curriculum design, and student outcomes. By showcasing PBL's benefits in improving attitudes, academic performance, problem solving, and soft skills, this research can drive the adoption of more engaging and effective instructional methods. It informs curriculum developers and policymakers on integrating real world learning experiences into mathematics curricula, while also guiding the teachers' training programs to enhance educators' ability to implement problem based learning and other innovative strategies. Ultimately, successful problem based learning implementation empowers students with critical skills for the 21st century and cultivates a deeper understanding and appreciation for mathematics, shaping their academic and personal success. So, this is my references. These are my references. So, that's all from me. Thank you very much.